In the records of human history lie secrets so extreme that their revelation could shake the very foundations of our understanding. One of these ancient secrets has been uncovered by Randall Carlson. His findings terrified the scientists. What is this discovery that has sent shockwaves through the scientific community? Join us as we unravel Earth's most ancient secrets uncovered by Randall Carlson. Unraveling Earth's Ancient Mysteries. Randall Carlson, an American author, researcher, and geologist, is known for his work in the fields of alternative history, natural tragic events, and sacred geometry. Carlson has been a prominent figure in the exploration of ancient civilizations and their possible connections to natural disasters and cosmic events. He is known for his interdisciplinary approach, combining geology, archaeology, and mythology to explore the possibility of advanced civilizations in prehistory and their potential interactions with cataclysmic events like comet impacts or volcanic eruptions. Carlson's work has sparked both interest and controversy in the scientific community, with some researchers supporting his ideas and others questioning the validity of his interpretations. Nonetheless, his contributions have opened up new avenues for research and discussion in the fields of ancient history, geology, and archaeology. One of his most notable contributions is his work on the Younger Dryas impact hypothesis, which suggests that a comet impact around 12,800 years ago may have triggered a series of environmental changes. The debate about whether a comet hit Earth around 12,800 years ago is still ongoing, even though there is strong evidence supporting this idea. The Younger Dryas impact hypothesis proposes that a comet caused significant changes in the climate and geology of Earth. This topic captures the imagination because it combines geological mysteries with dramatic climate changes. At the core of this hypothesis is a range of geological evidence. For example, nanodiamonds, which are formed under extreme pressure, have been discovered in sediment layers across North America, Europe, and parts of Asia that date back to the Younger Dryas period. The widespread presence of these tiny diamonds suggests a high-energy event on a global scale. Another puzzling piece of evidence is the discovery of microspherules, small spherical particles often associated with extraterrestrial impacts or volcanic eruptions. The high concentrations of these particles found in the Younger Dryas boundary layers further support the idea of a significant impact event. Additionally, other materials found in these sediments, such as elevated levels of iridium and magnetic grains containing iridium, provide further evidence of a large impact. The discovery of soot and carbon-rich layers in these sediments also suggests widespread burning, likely caused by wildfires triggered by the impact. These shock-produced hexagonal diamonds are unique because they don't occur naturally through any known process, except for the extreme heat and pressure of a cosmic impact. Evidence of this impact material, along with the extinction of various species about 12,900 years ago, suggests a significant event. This impact material contains iron oxide spherules within a glassy iron silica matrix, which is a sign that a meteorite may have hit. Then there are the Carolina Bays, which are oval-shaped depressions along the U.S. Atlantic seaboard. Near White Lake in North Carolina, several lakes are shaped like long ovals, stretching from northwest to southeast. But if you look around the area, you'll see many more similar depressions in the ground that aren't filled with lakes, but they all have the same shape. As you move away from the area, you'll find these features are common in other Atlantic coast states too. They're all called Carolina Bays because they were first described in the Carolinas. There are about 500,000 Carolina Bays across 10 states, from Alabama to New York. They're all shaped the same way, but no one knows exactly how they formed. Their origin is heavily debated. Some believe the Carolina Bays were formed during the last ice age. When the ice age was at its coldest, glaciers covered parts of the United States and Canada, including the area where the Carolina Bays are now. The cold air from the glaciers made the Atlantic Ocean and nearby land masses freeze for thousands of years. This created a layer of permanently frozen ground called permafrost. Over time, the permafrost started to thaw, forming small ponds on top of the ice wedges in the ground. As the ice melted, the ground sank and the ponds combined to form thermokarst lakes. Some of these lakes were filled with sediment, and most of them disappeared as the climate got warmer. According to supporters of this theory, the Carolina Bays are the remains of these ancient thermokarst lakes. Similar features can be found in Alaska and Canada today. The long axis of the Carolina Bays shows the direction of the prevailing winds when they formed. Some scientists believe they were made by an asteroid hitting the Earth, by wind blowing away the soil, or by water coming up from the ground. The Carolina Bays are usually between 800 and 15,000 feet wide and between 2 and 70 feet deep. Most of them are less than 15 feet deep. Sediment on top of the depressions has been dated to between 140,000 and 12,000 years ago. The alignment of these bays suggests a path of comets coming from the northwest. The climatic impact of such an event would be profound. Imagine a comet hitting Earth, throwing vast amounts of dust, soot, and particles into the atmosphere. This debris, spreading globally, would block sunlight, leading to a sudden drop in temperatures. This aligns with what climate models and ice core data from Greenland and Antarctica show: a sharp decline in temperatures around the time of the proposed impact, which seems to align with the theory of the Young Dryas period. A crucial period of climate change. The Younger Dryas period, named after the Dryas octopetala flower, was a fascinating time in Earth's history. It occurred around 12,800 to 11,500 years ago and marked a shift from the late Pleistocene to the early Holocene periods. During this time, there was a significant drop in temperatures, disrupting the gradual warming trend that followed the last glacial maximum. This sudden change led to a drop in temperatures of about 2 to 6 degrees Celsius over a relatively short period. The colder conditions affected the flow of meltwater from glaciers into the oceans, and there was a notable decline in this flow, or it may have even stopped altogether. About 1,300 years later, the meltwater flow started up again, known as Meltwater Pulse 1b. The effects of the Younger Dryas were not limited to the North Atlantic region, but were felt globally. Evidence of climatic changes can be found in regions such as Asia, South America, and even the Southern Hemisphere. These cold and dry conditions had a significant impact on vegetation patterns, ecosystems, and human populations that relied on hunting and foraging for survival. Adding to the puzzle of this period is the proposed comet impact hypothesis, which suggests that a comet impact may have contributed to the abrupt climate change during the Younger Dryas. This hypothesis is still a subject of debate among scientists. The theory suggests that a comet or pieces of it crashed into Earth or exploded in the atmosphere, possibly in multiple stages. This impact, which is compared to the energy release of numerous nuclear explosions, is believed to have sparked massive wildfires that engulfed vast areas of forests and grasslands. These wildfires likely played a role in creating the black mat layer, a deposit rich in carbon found at many Younger Dryas sites. Supporters of this idea point to evidence like microspherules and nanodiamonds, which typically form in high-impact scenarios, as well as heightened levels of rare elements such as iridium and platinum to support their arguments. The layer appears black because it contains a high concentration of soot, indicating widespread wildfires, possibly on a global or at least hemispheric scale, which may have occurred before the massive flooding that followed. Geological records also show layers of charcoal and soot from this period, indicating extensive burning. However, this hypothesis faces challenges and controversies. One major issue is the absence of a clear impact crater, which is typically expected from such a significant event. Proponents suggest that the comet may have broken apart in the atmosphere or struck an ice sheet, leaving no obvious crater. Critics offer alternative explanations for the shift in climate, such as changes in ocean circulation patterns or volcanic activity. The debate surrounding the cause of the Younger Dryas continues, with researchers exploring various possibilities to unravel the mysteries of this puzzling period in Earth's history. Carlson points out rapid temperature changes in Earth's history, especially highlighting events like the Younger Dryas, a time when the climate suddenly got much colder again after warming up. His view challenges the idea that climate changes happen slowly and steadily, suggesting instead that the climate system can be unpredictable and changeable. He looks at past events like the Bowling-Ala-Rod warming period before the Younger Dryas, where we see fast shifts in climate in records from the past. These events help us understand how sensitive and resilient Earth's climate system is. The cooling effect was powerful in the Northern Hemisphere, where temperatures dropped by an estimated 3 to 11 degrees Celsius in some areas. But that's not all. The comet impact could have also disrupted major ocean currents, like the Atlantic meridional overturning circulation, leading to even more cooling, especially in the North Atlantic. Around the time of the Younger Dryas period, something dramatic happened in North America: the extinction of many large mammal species. This included iconic megafauna like woolly mammoths, mastodons, saber-toothed cats, giant ground sloths, and even the North American camel and horse. These extinctions weren't spread evenly across regions, with North America being hit particularly hard. What is of interest is the timing of these extinctions, which coincides with the Younger Dryas period. This has led critics of the Younger Dryas impact hypothesis to suggest a link between the comet impact and these mass extinctions. Exploring the debate over climate change. Critics argue that the comet impact would have set off a chain reaction of ecological disruptions, including wildfires, climate change, and disruptions in the food chain. These sudden changes in the environment might have been too much for these large species to handle, making it hard for them to adapt and ultimately leading to their extinction. However, it's important to know that there are different opinions about this. Some scientists suggest alternative explanations, like the overkill hypothesis, which says that humans hunting too much may have played a big part in these extinctions. Others think that natural changes in the climate, not related to any impact event, could have caused the extinctions. During the events that ended the Ice Age, about half of the Earth's big species disappeared very quickly, around 12,000 to 13,000 years ago. A huge number of fossils from these species were found in the environment. But now these species are gone forever. Each square on the map represents a fossil from one of these extinct species. The debate continues, and the impact hypothesis is just one idea among many. The Younger Dryas impact hypothesis doesn't just affect animals. It also has implications for early human societies, especially the Clovis culture. The Clovis people lived a long time ago, from about 10,000 BC to 7,800 years BC during the Paleo-Indian era, and were known for their innovative stone tool technology. One of the most distinctive features of their missile points, which were used for hunting, was the presence of channels or flutes near the base. These flutes were created by carefully removing broad flakes from either side of the point, a process known as basal thinning. This technique was crucial for attaching the point to a spear shaft, making it more secure and effective for hunting. This seemingly minor detail in Clovis technology played a significant role in their success as a group. It allowed them to quickly spread across North America and even down to the southern tip of South America in just around 1,000 years. This rapid expansion is remarkable and is attributed in part to the efficiency of their hunting tools. The Clovis people were nomadic, living in small groups, and were skilled hunters of large animals like mammoths and mastodons. Archaeologists have found evidence of their presence at various sites where mammoth and mastodon remains were discovered alongside Clovis artifacts. One such site is Mastodon State Park in Kimmswick, Missouri, where artifacts from the Clovis era have been found. Researchers have noticed a link between the apparent disappearance or change in the Clovis culture and the beginning of the Younger Dryas period. This suggests that the proposed impact event might have greatly disrupted the way of life for these ancient people. The sudden shift to colder, drier conditions during the Younger Dryas would have surely affected the availability of food and resources for these hunter-gatherer communities. The changes in big animal populations, which were crucial for the Clovis people, would have made these challenges even harder. There's archaeological evidence supporting this idea of adaptation. We can see a clear change in human tools and how they lived after the Younger Dryas, showing they were responding to new environmental conditions and what resources were available. This time also marks the emergence of more different cultures in different regions compared to the widespread Clovis technology. Randall Carlson's theory suggests that advanced human civilizations lived long before we usually think civilization began. These civilizations might have even been around before the last ice age, which ended about 11,700 years ago. This goes against the usual idea that civilization started much later, like with the Sumerians and ancient Egyptians about 6,000 years ago. Carlson thinks that these ancient societies were not just good at technology, they also had deep spiritual understanding and wisdom. He thinks they might have been able to build advanced buildings, study the stars, and do other sciences that we usually think were only done much later. To support his theory, Carlson looks at the complexity and sophistication of ancient buildings like the pyramids in Egypt, Stonehenge, and other big stone structures around the world. He says that the way these buildings were made, how they lined up with the stars, and the skills needed to build them show that people back then knew a lot more than we usually think. Many of these buildings line up exactly with important days in the year, like the longest and shortest days, which Carlson says shows that people back then knew a lot about the stars. For example, the layout of the Giza Pyramid complex lines up with the 3 stars in the belt of the Orion constellation, while Stonehenge lines up with the longest and shortest days of the year. One of Carlson's main ideas is that these advanced ancient societies might have been destroyed by big events like comet impacts or other natural disasters. These disasters might have killed a lot of people and made them lose their knowledge and skills. He also thinks that some of this lost knowledge might still be in stories, religious texts, and old symbols from different cultures. According to Carlson, these old stories and symbols might have hidden meanings that talk about real things that happened and the lost knowledge from these ancient civilizations. However, Carlson's ideas are different from what most archaeologists think. Graham Hancock's Global Pyramid Connection archaeologists usually say that people back then were just starting to learn how to make things and that they didn't know much about the world. But Carlson thinks that maybe these ancient people knew a lot more than we think and that they might have been a lot more like us than we thought. In the world of ancient mysteries, Graham Hancock's Global Pyramid Connection theory stands out because it has some big and controversial ideas. He talks about a fascinating connection between the pyramids and big stone structures found all over the world. These include the big pyramids in Egypt, the detailed stone buildings made by the Mayans and Aztecs in Central and South America, and even the less famous pyramids in China's Shaanxi province and the mysterious Gunung Padang in Indonesia. Hancock thinks there's something they all have in common. He thinks that either one really smart civilization made all of these amazing buildings, or that different groups of people shared their knowledge and that's why they all look similar. These buildings mean different things to the different cultures that made them. Each civilization had its own beliefs and traditions, so they thought of these buildings in different ways. But what's interesting is that pyramids, as a type of big building, are found in lots of different places. Hancock thinks this is cool. The times when these buildings were made are also different. The big pyramids in Egypt were made around 2700 BCE, while the big stone buildings in Central and South America were made until about 900 CE. Hancock thinks that these buildings show how smart people were back then. He thinks that we don't understand how smart they were and that we don't think it's important. Hancock is really interested in how these buildings were made. He thinks that the way they were built is amazing. The Great Pyramid, for example, shows this kind of precision. Its stones and joints are perfectly lined up, often without any mortar. This level of accuracy in the stonework, especially considering when these buildings were made, is something that still surprises a lot of people. The huge stone blocks used in these buildings, some of them weighing a lot, show that the people who built them knew a lot about how to make big buildings, even though they didn't have the same technology we have now. What's interesting is that these buildings were made at a time when people didn't have the same technology we have today. These pyramids and big stone buildings make us wonder how much the people who made them knew and what they could do. Were they just really good at building things? Or did they get help from somewhere else? Maybe from a civilization that we don't know about anymore. Hancock's idea of an advanced ancient civilization is very different from what most people think. He thinks that there was a civilization that was smart more than 10,000 years ago, way before the earliest known societies like the Sumerians and ancient Egyptians, which we usually think started about 6,000 years ago. Hancock's idea is that this civilization was good at things like looking at the stars, building things, and doing math. He thinks that the way these ancient buildings line up with the stars, like the Great Pyramid of Giza, shows that these people knew a lot about the stars and how they move. Then there's the Pyramid of Kukulkan at Chichen Itza, known as El Castillo. During the equinoxes, the way the light and shadows play on it makes it look like a snake is coming down the steps. This is a great example of how smart the ancient people were. They knew a lot about the stars and how they move, and they built their buildings to show this. One of the most interesting parts of Hancock's idea is the Orion correlation theory. He and Robert Bovell came up with this theory. They say that the way the three big pyramids at Giza are built lines up with the three stars in Orion's belt. Hancock thinks this isn't just a coincidence. He thinks it's a way for the ancient people to show how much they knew about the stars. Hancock says that the signs of civilization that we see coming up aren't the first signs of civilization. He thinks they're a new start. But where did this knowledge come from? Some people point to big stone buildings like Göbekli Tepe in Turkey, which is from about 10,000 BCE. These buildings are old, but they're also really complicated. They're built so that they line up with the stars, which shows that the people who built them knew a lot about the stars and how they move. Hancock doesn't stop there. He also talks about old maps, like the Piri Reis map. He thinks that this map shows that people back then knew a lot about the world, maybe more than we think they did. Hancock's idea is that this old civilization was really smart, but then something bad happened, like a comet hitting Earth around 10,500 BCE. This bad thing killed a lot of people, but some survived. They went all over the world and taught the people they met how to do things, like building big buildings and studying the stars. Now, what if we put two different ideas together? What if the old civilization that people talk about, the one that came from the stars, was the ancient Anunnaki? Ancient aliens or fictional beings? Zecharia Sitchin's ideas about the Anunnaki and how they're connected to Earth have made a lot of people talk about this, both in science and in other places where people talk about history. According to Sitchin, the Anunnaki weren't just gods from ancient Mesopotamian stories. They were aliens from a faraway planet called Nibiru. He says that this planet goes around our sun every 3,600 years, and when it gets close to Earth, it changes our history in big ways. It sounds like something from a science fiction book, but Sitchin thought that his ideas were true because of what he found in old Sumerian and Mesopotamian texts. He thought that these texts were telling us about real things that happened, not just stories. Sitchin's story is about why the Anunnaki came to Earth. He thought that these aliens were looking for things, like gold, that they needed to fix up their home planet's air. But Sitchin thought that the Anunnaki did more than just look for gold. He thought that they used their really smart technology and what they knew to help build some of the amazing buildings we see from ancient times, like the big pyramids in Egypt and the ziggurats in Mesopotamia. One of the things that Sitchin said that got people talking was his idea that the Anunnaki changed the way people are. He thought that the first people were made by the Anunnaki mixing their DNA with the DNA of the first people on Earth. He said that this made people grow up faster and made them do things that changed the way our world is today. Sitchin's ideas are really big. He said that the Anunnaki didn't just make big buildings. They also taught people things that helped them grow. This idea changes the way we think about how people started to learn things. It makes us think that maybe aliens helped us learn things too. Suddenly we see signs of people learning things and building big things, like at Göbekli Tepe. This makes us think that people back then knew a lot more than we thought they did. The idea that the Anunnaki, a group of gods from ancient stories, helped build big things on Earth, is a story that makes us wonder. People who like this idea think that the Anunnaki weren't just made up, they were real aliens. They think that the Anunnaki came to Earth and helped people build things that we still think are amazing. These people think that the Anunnaki were a lot smarter and better at making things than the people who lived on Earth at the same time. They think that Anunnaki's help is why we have things like the big pyramids in Egypt, the big stone things at Stonehenge, the big statues on Easter Island, and the big pyramids in Central and South America. The people who like this idea also think that the way these big things were built shows that the people who built them knew a lot about the stars. For example, the way Stonehenge is built shows how the sun moves during the longest and shortest days of the year. People who like this idea also think that the way these big things look is the same, even though they're far apart. This makes them think that there was someone who taught people how to build these things, and that this someone was the Anunnaki. This idea also talks about when the Anunnaki came to Earth. Some people think that they came when there was a really big flood or something else that was bad. This idea of when the Anunnaki came to Earth is really interesting. Some people think that they came at a time when things were really bad for people on Earth. They think that maybe the Anunnaki came to help fix things, or maybe they came to take things from Earth when people couldn't stop them. This part of the idea is like what we see in old stories from different places. These stories have gods or other special beings coming to Earth when people need help. Some people think that these stories aren't just stories, they're true. They think that these stories are telling us about real things that happened, like the Anunnaki coming to Earth. Some stories, like the one about Noah in the Bible and the one about Gilgamesh in Mesopotamia, talk about really big floods that happened when the Anunnaki came to Earth. Some people think that these stories are telling us about real things that happened, not just stories that people made up. Even though this idea is really interesting, it's not something that most people who study history and old things believe. This is because there isn't any proof that it's true, and because it's mostly just people guessing about what they think might have happened. But even though most people don't believe it, it's still something that a lot of people like to talk about and think about. There are a lot of people who like to think about what might have happened a long time ago, and this idea is one of the things that they like to talk about. What are your thoughts on the secrets revealed by Randall Carlson? Let us know your opinion in the comments below.